All right, boys and girls, have out your study guide that you picked up on your way in. We're going to go over the first study guide for the Science End of the Year test, and that is over soil. So we're going to look at studying soil today, and then later on we're going to look at rocks and minerals, characteristics of life, and cells. And then in our last unit that we did is bodywork. So all these units and that material will be on the Science End of Year test that you will be taking, okay? So let's get into it. As I go over this, you can pause this video to write things down because I am going to go over it rather quickly. I'm also going to emphasize some things here. So when a teacher emphasizes something, please pay close attention to it. I would maybe even star or underline or circle it, okay? Because that is probably a guarantee that you're probably going to see it in some way, form, or fashion on the end of the year test. So let's look at what is soil. Soil is a mixture of rock particles, minerals, decayed organic material, water, and air. Soil forms as rock is broken down by weathering and mixes with other materials on the surface. Soil formation also begins, I would maybe write this down, with the weathering of bedrock. It doesn't say that here, but I would like you to maybe just add that little note to also realize that soil formation also begins with the weathering of bedrock, that solid layer of rock that is deep below all the soil layers that we're getting ready to go over. That weathers and contributes to the formation of soil as well. How do scientists describe soil? They describe soil based on color, texture, and consistency, okay? So when they look at soil, they describe it based on those three things. They look at the color, they look at the texture, and they look at the consistency. Now I'm going to not define color for you. Hopefully you know what that is. But let's look at texture. Texture refers to the feeling of material on the skin. Soil either has a grainy texture, a gritty texture, or I'm sorry, a grainy texture, it feels gritty, a silky texture, and a sticky texture. So the types of textures are grainy, silky, and sticky. And I'm not going to read those descriptions to you, but you can read those for yourself. Consistence is the resistance of soil breaking apart. Soil either has a loose consistence, a friable consistence, or a firm consistence. Now let's look at the soil layers. I'm going to describe them first and then show you a picture of them. Soil, or topsoil, a horizon, is a combination of rocks, sand, clay, organic matter, air, and water. Plant roots grow deep in this layer, which is rich with biological activity. Topsoil is about 20 centimeters deep, but it may be thinner or thicker depending on location. So in this layer of soil is where you find biological activity. Biological activity is life. So you're going to find rodents, you're going to find worms, and you're going to find bugs, okay? All these is biological activity that you will find in topsoil. Now let's look at the next horizon, which is B horizon, also known as subsoil. Subsoil contains some of the chemicals found in the topsoil as water drips from the soil above and washes these nutrients down. There's not much organic material in this soil or in this layer. You'll find clay minerals, and little humus here. Again, there is not much organic material found in this layer. Okay. Next horizon is C horizon, or parent material. This is made up of slightly broken up bedrock. Plant roots usually do not penetrate in this layer. Very little organic material or matter is found here. And then the fourth and final layer is bedrock, and it's hard rock that lies beneath all the soil layers. Okay? So again, here's a picture of it. A horizon, which is topsoil. B horizon, which is subsoil. C horizon, which is parent material. And then the bottom layer is bedrock. So again, biological activity found in this layer. You have mice, you have different types of bugs, you have worms. All this will be found here, and all this contributes to the formation of organic material, humus. We'll talk about that in just a second. Notice in this picture here that the plant roots do not penetrate down into B horizon. That's why you find very little organic matter in B horizon. Definitely none in C horizon, or very little, and almost zero to none in bedrock. So how do living things affect soil? Kind of already talked about this a little bit. Some soil organisms and worms mix the soil, make it spaces in it for air and water. All right, going back to that last question real quick. Soil organisms such as worms, they are, you know, eating leaves, eating other material, and they're also pooping, okay, in the soil. And that is what contributes to humus, and that is what makes soil fertile, this organic material. All right, what are the three types of sediment particles found in soil? List them from largest to smallest. Here you have sand, silt, and clay. What do sediment sizes, particle sizes help determine in soil? Particle size in soil determines the amount of air and water that can be found in soil, or how much air and water the soil can hold. Loam describes the soil that is rich, fertile soil that is made up of about equal parts of clay, sand, and silt. Loam is considered to be the best type of soil for growing plants. Okay, so here again is a picture, and you can see, okay, if I have soil that has a lot of sand, when I pour water, the water is just going to soak right through, okay? And it's going to be very hard for sand to hold this water. It's going to be very hard for sand to have organic matter in it because the water just washes it right out of it, okay? Look at silt. A little bit more compacted than sand, but still a lot of air, a lot of space in here. So it'll take water a little bit more time, and silt definitely will hold organic material in the soil longer because the water just can't flow right through it. But again, it still has airspace here. You can see that's the white. With clay, okay, clay is very compacted. You can pour water on this, and it will just take forever for it to soak through. Okay, so clay will hold organic matter for sure for a longer period of time because it takes forever for the water to completely soak through. Now, again, loam. Loam describes the soil that is rich, fertile, and made up of equal parts clay, sand, and silt. You want a soil that is a nice mixture of all these. You don't want too much clay, too much silt, because then it'll hold too much water. Then obviously you don't want too much sand because then it won't hold enough water. And again, that water soaking through will just wash that organic matter right out of it if it has lots of sand in it. So for good, rich, fertile soil, you like to have that loam, that equal mixture of all three particle sizes. All right, humus. Humus is a dark-colored organic material in soil. It forms as plants and animal remains decay. Humus helps create space in soil for air and water. Humus also contains nutrients that plants need. Very, very, very important. Why is organic material important for soil? Organic matter contributes to the amount of nutrients that are in soil. Nutrients are essential for plant growth. There are three types of nutrients important for plant growth: nitrogen, phosphorus, and potassium, okay? So organic matter contributes to nutrients. So as a leaf falls to the ground, it starts to decay, turns into humus. The humus then turns into organic matter that then provides the nutrients into the soil for other plants, for grass growing in that soil, for flowers growing in that soil, trees growing in that soil. Okay, organic matter contributes to the amount of nutrients that are found in the soil. If you don't have organic matter in the soil, you are not going to have the nutrients. Therefore, the soil is not going to be very fertile, and you're not going to be able to grow anything. How can soil lose its value? The value of soil is reduced when soil loses its fertility or when topsoil is lost due to erosion. Okay, soil loses fertility through the loss of moisture and nutrients. Loss of topsoil occurs whenever soil is exposed. Water and wind can quickly erode it. Okay, we're going to talk about this here in just a second. The example of the dust bowl, prime example of what happens when you remove all the plant cover. You expose that soil. The wind comes along and picks it up, and it takes away that top soil. That's rich with biological activity, right? So once that stuff is gone, there's nothing left to contribute to the nutrients that you would find in the organic matter. Therefore, the soil would lose its value. It would not be very valuable because you can't grow anything, okay? So when soil is exposed, that enables water to quickly wash it away. That allows wind to quickly pick it up and carried away. Okay. What was the Dust Bowl? What caused the Dust Bowl? So the Dust Bowl was a decade-long ecological disaster that was brought on by high temperatures, sustained drought, and high winds. These weather conditions, combined with the poor agricultural practices, caused the devastation referred to as the Dust Bowl. Three contributing factors to the Dust Bowl were the removal of native plants, dry soil from a long period without rain, and strong winds. Okay, we learned some hard lessons in this, and you hopefully remember from watching that video that we learned that you just can't go and till up a bunch of land and expect that year after year it's going to rain with consistency, because they found out that you had this period of drought. It dried up the soil. Once the soil is dried up, the winds picked up and carried the stuff out of there, and it left just almost a desert, barren wasteland there. It took them a very long time to recover. How can soil be conserved? Okay, these are the different practices that we learned from the Dust Bowl: contour plowing, conservation plowing, crop rotation. Contour plowing is when farmers plow their fields along the curves of a slope instead of straight rows. Conservation plowing is dead weeds and stalks of the previous year's crops are plowed into the ground to help return soil nutrients, retain moisture, and hold soil in place. And crop rotation: a farmer plants a different crop in a field each year. Pay attention to what's going to be planted this year. It'll be different from what you saw last year around the middle school. Why is soil management important? Okay, without soil, most life on land cannot exist. Poor soil management can result in three problems: erosion, the process by which water, wind, or ice moves particles of rock or soil away; nutrient depletion, when soil becomes less fertile; or desertification, the advancement of desert-like conditions into areas that were previously fertile. Okay, last question. What do plants need in order to grow? Light, air, water, and nutrients. Okay, so that will wrap up the study guide for soil. Boys and girls, this is a big test. You're going to see again multiple units, multiple concepts. It's important that you take this study guide, look over it, practice it, and prepare for this science end of year test. All right, have a great day.